Welcome everybody. So I want to show you how to solve electromagnetic wave problem. So here transverse electromagnetic plane wave in a lossless non-magnetic homogeneous medium. I would like to discuss about this lossless. That means no loss, and non-magnetic means mu r equal to 1. And homogeneous linear isotropic source free medium has ER equal to 16, and this is the electric field expression given. So in this electric field expression, so you see this 30 pi is the magnitude of the electric field, and this will be the phase angle 4 pi, or phase constant. Then y is the propagation direction, and x is the polarization direction. So just the information that we can easily explore from here is the amplitude, the phase constant, the propagation direction, and the polarization direction. So now let me solve the question here. So the part 1 says find the phase constant. Phase constant is beta, and beta is this value here. So just don't put the sign here, just the number with the axis variable y. So beta will be 4 pi. Don't put the variable y, no j or the sign. So only 4 pi. So just b equal to 4 pi. So I didn't take the sign, consider the sign, not j, not the axis variable, 4 pi, and the unit is radians per meter. So this is my first quick answer. Part 2. Part 2 says find the intrinsic impedance. So intrinsic impedance or the wave impedance is like the formula is intrinsic impedance equal to mu over epsilon. So you have to know this formula. This formula will not be given on the formula sheet. Actually, no formula sheet will be given. So you can write down the formulas. Intrinsic impedance is mu over epsilon, so equal to mu naught over epsilon naught times mu r epsilon r. So here mu naught over epsilon naught is known. So that's the free space impedance. So if I divide separate mu naught epsilon naught and mu r over epsilon r, so you can write that mu naught epsilon naught is 125. So I recommend you know this number, mu naught over epsilon naught. So this value is basically 125 ohms. That's the intrinsic impedance of free space. And then mu r, as it is non-magnetic, so mu r is 1 and epsilon r is 16. So 1 over 16. So that will be 435. 35. The unit is ohms. Then find the propagation speed of the wave in the medium. So the propagation speed is basically u. So u is 1 over square root of mu times epsilon. Write it like 1 over mu naught epsilon naught and mu r epsilon r. So 1 over mu naught epsilon naught is the speed of light. So this part is equal to 3 times 10 to the power 8 meter per second. So here we have 1 times 16. So that will be 3 over 4. So that is 3 over 4 will be 0.75 times 10 to the power 8. So 10 to the power 8 meter per second. Sorry, meter per second. That's the speed of propagation. So now if I solve for 4, part 4 says the wavelength of the wave. So wavelength is equal to lambda. Lambda is equal to 2 pi over beta. So here 2 pi and beta equal to 4 pi. So that is 0.5 meter. And then you have to write 5, the frequency. Frequency equal to, so you can use F equal to, so U over lambda. So U is 7.5 to the power 8 and lambda equal to 0.5. So that will be 1.5 times 10.8. So 150 megahertz. Then we have to solve for the unit vector in the direction of propagation. So you can solve the unit vector in the direction of propagation. So here the wave is propagating in, so wave is propagating in positive y axis. So if you see here, the sign is negative. This negative sign, negative indicates positive direction. And y is the direction axis. So that means I can write it like AP equal to AY. Then you have to find the frequency domain magnetic field intensity. So we can do in two methods. One is using Maxwell's equation. So Maxwell's equation says that curl of ES is equal to negative j omega mu SS. So you can write SS equal to 1 over negative j omega mu curl of ES, where 1 over j omega mu curl of ES is AX, AY, AZ, partial over partial X, partial over partial Y, partial over partial Z, then EX, EY, EZ. So now if you substitute this, I write down here, I got 1 over j omega mu negative, and we have AX here, AY, AZ, and here there is, if you look at the expression, it has Y and X. So only AX component for E, and it is function of Y only. So we have no derivative of X will be 0, derivative of Z will be 0. We have the derivative of Y only. And also we have X component. So we have to write 30 pi e to the power minus 4 pi Y. And this Y component is 0, Z component is 0. So just for third row, you have to look at AX. So you have only X component. So write down only AX coefficient here. And for second row, you see we have the function is only varied with Y. So you write only partial derivative of Y. So now If I expand this, j omega mu, so expand this, for ax will be 0, ay will be 0 to az. So for az you will get az direction, you will get 0 and minus partial y 30 pi e to the power 4 pi y this. So now if you solve it, so there is uh, two negatives, so you can write positive 1 over j omega mu, so that is j2. So we have uh, 30 pi and negative j4y 4 pi e to the power negative j4 pi y. We cancel out j and j, so this is 120 pi square omega mu e to the power negative j4 pi y a z. So it has a z here too. So this is 120 pi square and omega equal to 2 pi and f equal to 150 times 10 to the power 6 and mu equal to mu naught times 1. So mu naught is 4 pi 10 to the power negative 7 to the power negative j 4 pi y z. So now you can cancel this pi with this pi squared, and there is 2 and 4. So in the top we have 120 and in the bottom we have 2 times, there is 0 on 0 6, so 10 to the power 7 and there is 10 to the power negative 7, so you can write 15 and you can write 4. So that will be 60 over 4, that is 4, 15, 15. So that's basically 1. So e to the power minus j 4 pi y az, and the unit is amperes per meter. So this is very complex approach for solving this using Maxwell's equation, but however we can easily solve this with TEM equation. So I'll show you how to solve it with TEM equation. So TEM equations basically a very simplified equation here. So it's very simplified expression like this. So you can write ACES is equal to 1 over eta S cross AP. So 1 over eta we already found in previous expression, that was 30 pi, and ES is 30 pi e to the power j 4 pi y ax cross AP is ay. So that will be 1, 30 pi cancels, so e to the power negative j 4 pi y az, ampere per meter. So this expression is very super easy, but if we ask you to solve the magnetic field or electric field using Maxwell's equation, then you have to use the curl expression to solve it. But if we don't mention the Maxwell's equation, or if we don't mention anything to, we can apply any method to solve it, then this formula is easier. to solve this. Then you have to find time domain electric and magnetic field. So time domain electric field is ET. So here we have the magnitude is 35 and we write cosine. The frequency is 2 pi f equal to 150 times 10 to the power 6. So 2 pi f, right? 2 pi f omega times t minus 4 pi y ax volt per meter. This is the answer for part 7, 8, sorry, part 8. And for magnetic field in time domain will be cosine 2 pi. If you don't want to put the frequency, you can write like simply like omega t minus 4 pi y. The direction is az, ampere per meter. Then the last part is the total power loss. We didn't cover power loss in the course yet, but still power loss we can easily uh, find here without doing any mathematical expression, because the power loss, the medium is said to be lossless medium, so power loss will be 0. So without solving any expression, we can say is a lossless medium. Okay, so lossless medium, power loss will be 0. So that's how we can solve any question. So in the test, you will be given this question as a multiple choice question. It will be a multiple choice. So practice this question. You can write down the formulas if you need, but make sure that you write the correct answer. Things we might ask you to show you the working. So in addition to the multiple choice question, you might need to submit your working through emails. So this is an important question for the midterm test.